Hi everyone, so I hope you're doing well. In this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is check if strings are rotation of each other or not, right? And I don't know like if this is a new difficulty level. The difficulty is basic. Let's just read the question. It says that we have been given two strings of equal length S1 and S2, and our task is to find if S2 is a rotated version of S1 or not. Okay. So uh, there's one thing that like the very first thing when you notice whenever you see this type of question is, let me just take the screenshot. So if I just move it here, so you see what I did was, if I write the same thing twice, right? So this is the new string that I have. I written the same string twice. Now if there was any rotation, for example this one for geeks, so you will find the rotation from here, right? For geeks, right? You will be able to find the complete string. Whenever you want to find any rotation, if you write the same string twice and the rotation version is present in this whole string, that means it is possible to rotate the original string and get the second string. If you are not able to find in the concatenated version, that means it is not possible to obtain the rotated version. Now here it was possible, so you were able to find this particular term for geeks. But so this is a very like I would say a general concept. But the problem is finding this pattern is not easy, right? So I don't know like why they have mentioned the time complexity to be O of n only, and the space complexity is O of n as well. But generally what happens is, if you use any simple methods to find the patterns, or if you want to find a pattern, the expected time complexity is always O of n square, right? It is O of n only when you use some kind of pattern matching algorithm such as KMP. You can use KMP algorithm or you can use Z algorithm, right? So you can use these pattern matching algorithms to find the answer is O of n, but I don't think there exists any other way of finding the answer in O of n. The time complexity is, if I write an n square algorithm, it might overtake. So there is also a s dot find function. It is an inbuilt function. However, I have read the documentation. This the documentation does not specify the complexity of this particular function. There is no like specified complexity, but it is expected that it will be n square only. So let's just try this once, because this is very easy to write. I don't have to worry much about it. So s1 plus is equals to s2. That means I'm writing the same string twice, and I'm just going to turn s1 dot find s2 is not equals to. So I don't know like if this is the correct method to write it or not. Yep. So we have this website. Yep. So whenever we don't find it, we write it equals to this string in pos, right? But also you will see here there must be the time complexity somewhere, right? You see the time complexity of this function is unspecified, but it is linear in terms of length pos times the length of the sequence to match. So the length of the string multiplied by pos times which is the length of the sequence to match. So it is also n square, not O of n, but I believe this is correct. So if I can just compile and see, I don't know whether this is going to pass or not, because it might be n square, but let us just submit this. Surprisingly it does pass, but I still don't know why. So look, the thing is, this function might have the worst case time complexity of O of n square, right? Here also you can see that they say that the time complexity is not mentioned, it is unspecified here, right? I don't think that this works in O of n actually. It might, we still don't know the internal implementation, but if you don't want to use this, and any other way of doing it in O of n is using either KMP or Z algorithm, right? Any pattern matching algorithm that you find. Now I just want to check the editorial ones, what they have said. So they have done the same thing, but this is not the correct way of solving this, I believe. Yeah, so they have I believe shown a couple of other methods as well, n square methods, but definitely like we cannot rely on this particular method only because the time complexity is unspecified here on the C++ documentation, right? That is why, that is the only reason I'm saying not to rely on this particular function, but yeah, you can use it normally. So that was it for today's video. It was surprisingly short. So you can do this, but if you are interested, then definitely check out this KMP and Z algorithm. It will actually help you to find the this particular answer in O of n, right? Actually, it is O of n plus n, right? But like overall, it is O of n only. So that was it for today. I hope that you guys were able to understand the solution. And so, like I know, like a lot of people watching this video might have been here just because of this particular doubt only. So that is why I tried to be as clear as possible. I showed you the document, I showed you the documentation, I showed you the official editorial. They have mentioned this method, but it's still better to use your own implementation of any pattern matching algorithm. That is it for today. So let's end this video now. Until the next video drops, keep coding, stay safe, bye bye.